Robust statistics. Robust statistics are measures that do not change easily with the change of a single or few data points. So let's take an example here from the textbook to visualize what this means. So suppose initially you have a data set like this. Let's call this the original data set. And suppose that, well, the data set looks like this with these values. And suppose that in another kind of data set or another sampling, let's say that you do, or the other context that you want to examine, instead of this value here, which is 26.3%, we actually end up with a value here at 15%. And, or suppose that instead of either of these two, we actually have this value that was here at 26 or at 15, we actually have it at 35. So what happens with these measures of variation when we see kind of a few different extreme values change across distributions? Well, for this exact data, this is what we see. The median remains the same, essentially, across these three, exactly the same. The interquartile range remains the same, exactly. But if we look at the mean and the standard deviation, they change. That maybe doesn't seem too much. At least not the mean doesn't seem too much, but it certainly changed noticeably. And the standard deviation also noticeably changed to 4.61 to 5.68 to 5.05. In other words, we say that the mean and the standard deviation are not robust because they change easily with the change of a few extreme values. So you need to, this is one of the main differences between these two sets of measures. So which is more affected by extreme observations, the mean or the median? And is the standard deviation or IQR more affected by extreme observations? When is it better to use the mean and standard deviation? When is it better to use the median, not media? What is it? Median and IQR. Well, it's going to depend on the context. But generally, if you do not want your data to be affected by the extreme values, if you do not really want to consider very strongly those extreme values, then you use the median and IQR. If you do want to consider those extreme values, then you use the mean and the SD, the standard deviation. Here's another example of some of the data we looked at before. If we have a data like this, would it be better to use the mean or the median? Well, because we have this outlier here, because we have this extreme observation, it's going to pull the mean and the standard deviation values pretty up high. It's going to pull these values here up high, and it may give you a wrong or not great view of your typical values. So your typical values are within here, right? These are the typical values. So in this distribution, in this data set, the mean and the standard deviation are going to be largely impacted by this extreme value. That's why we call them not robust. So in this case, it may be better to use the median and the IQR because they're more robust and they're not going to be impacted by the extreme value. And we actually have an example here of what we looked at before regarding the two markets for the farmer that we saw. So we have the various measures of central tendency, or let's call it the typical or average values, and of the variation as well. So because in because we're seeing a few kind of extreme values, certainly in the market one, with this 85 over here, which is what we saw here. And in a way, a little bit maybe in market two as well, we have another extreme value here, but maybe it's not that extreme, or at least it's less extreme than here on market one. We may want to compare these two via the median rather than the mean, in which case we would see that market one had actually more pounds in general, more pounds sold as a typical sell, as an average sell, because the amount of pounds sold is 27, whereas the amount of pounds sold in market two is 25. Now, once again, if you use the mean, you'd have a different view. You would say they're close together, or market two is slightly a better typical sell of quantity sold. All right, so depending on the measure that you're using, you're going to have a different view of the data. The standard deviation and the interquartile range, they're in the same direction. So market two is lower than market one, but the interquartile range is much smaller here in market two. It's half of the size compared to here. In other words, market two has much less variation, right? The interquartile two is fairly small, so less dispersion compared to market one, right? Market two, less than market one in terms of dispersion, considerably less. So we'd see that in the standard deviation, but we also see that very drastically in the IQR, which helps us understand the variation across these two measures. They're both useful. They're both good to have. They're easy to calculate, but these are some of the considerations that we need to have when we use these measures. Okay, that's it for this one. See you next time.